Hello students. So in our previous video of matter in our surroundings, we have learned what is matter, the particle nature of matter, and the characteristics of the particles of matter. Now in this session, we are going to learn about the various states of matter. So in this session, what we are going to see is the states of matter, the solid states and its properties, liquid state and its properties, the gaseous state and its properties, and the other states of matter. States of matter. Matter can be classified into various states based on its physical properties. So this classification is based on 3 points, that is the particle arrangement in the matter, the energy of the particles, and the distance between the particles of matter. So on these 3 points, we classify matter in 5 states. Earlier you have learned that there are 3 states of matter, that is solid, liquid, and gas. So these 3 states of matter exist under normal condition, whereas there are 2 more states of matter, that is the plasma state and the Bose-Einstein condensate. These 2 states of matter exist under very high and very low temperatures. So these states don't exist under normal condition. So we broadly classify matter in 3 states, that is solids, liquid, and gases. And these 2 states we'll learn a bit in the later slides. The solid state. So the substances which have definite shape and a fixed volume are called solid. So what does it mean? Let's see, there are a few examples of solid: a book, pen, ice, chalk pieces. All these things we call them as solid because they have a fixed shape. The shape of book remains same. It is always same and it occupies a fixed space. So I say it has got a fixed volume. So such things which have got a definite shape and fixed volume are called solids. In solids, the particles are very closely packed. That means the space between the particle is very less. So these particles are held tightly by a strong intermolecular force. So in solids, we have closely packed particles which are held together with a strong intermolecular force with very little space in between the molecules. Now let's see what are the various properties shown by solid state. Properties of solid state. So the first property of solid is solids have definite shape and fixed volume. So just now we have seen the definition of solid, which says the solids have definite shape and have fixed volumes. Now next, now we have seen in our previous slide that the particles of solid are very closely packed, or there is very less space in between the particles. So these particles are unable to move. That's why the particles of solid have negligible kinetic energy. Since they don't have space to move, they cannot move from one place to other, and that's why they possess very little kinetic energy. These particles simply keep vibrating in their places. Now next property says solids are rigid. Now what does it mean? So rigidity is the property of any substance to maintain their shape when they are subjected to external force. Say if I try to hammer a pen or drop it down, then it doesn't change its shape. Sometimes it may break, but it won't change its shape. So this property of solids to retain their shape is known as rigidity. But you may say there are some solids like spring or rubber band. They change their shape when we apply force on it. When I stretch a rubber band, its shape will be changed. But when I remove this external force, they regain their shape. So this property of solids or of any object is known as elasticity. So the property by virtue of which a substance changes its shape on applying a force and regains it again when the force is removed is called elasticity. So some solids show elasticity. Now the next property says solids cannot be compressed normally as the particles are tightly packed. Say if I have a chalk piece and I try to press it hard, it won't change its shape. It will remain as it is. I cannot press it and change it. So this property is known as compressibility, and solids don't show compressibility. But there are some exceptions like sponge. So how a sponge can be compressed? We can compress a sponge because it have got tiny holes, and in these holes air is trapped. So when I compress a sponge, this air is released out and we can compress the sponge easily. Now next property says solids have high density. Now what is the meaning of density? Density means the mass per unit volume. Since the particles of solids are tightly packed, they have more per number of particles in small volume. So that's why solids are highly dense, or I say they have high density. Now next property says solids generally do not show diffusion. Now what is diffusion? Diffusion is the process of intermixing of the particles of two different types of matter on their own. So this property is known as diffusion. Now since solids do not have space in between the particles, they don't diffuse into each other. In our previous slide, you must have seen that we dissolve salt or sugar in water. So this solid gets dissolved in water, but two solids cannot diffuse into each other. That's why we say that solids do not show diffusion property. But there are certain exceptions like camphor or naphthalene ball or the dry ice, which shows the diffusion property. The liquid state. So whenever we think about liquid, what comes to our mind? Flowing water comes to our mind, isn't it? So The substances which have an ability to flow and have a definite volume are called liquids. So few examples of liquid around us are water, milk, cold drink or juice, etc. So in liquids, the particles are somewhat loosely packed. So if I see a liquid and its particle, you can see there are certain spaces or gaps in between the particles of liquid. So this intermolecular space between the particles is more as compared to solids. In solids you have seen there is very little space, whereas in liquid we would have more space in between the particles. And the intermolecular force between these particles is also less as compared to that of the solid. Since they are loosely packed, the force of attraction also is less in case of liquid. Now let's see the properties of liquid state. Liquids do not have a fixed shape. They take the shape of the container in which they are stored. So you must have observed when you pour the water from bottle into a glass, the water will take the shape of glass. Earlier it was having the shape of bottle, but once I pour it in the glass, it would take the shape of the glass. So these liquids, they don't have fixed shape. The shape keep on changing as per the container in which they are stored. Whereas liquids have fixed volume. Now what does it mean? Say if I have 50 ml of water, then even if I am pouring it in a water bottle or in a glass or in a jug, the volume will remain same. That means the quantity of water will be 50 ml only. It will occupy the space of 50 ml in every container. So the volume is fixed. Though the shape is changing, the volume of liquid is fixed. Now let's see the next property. The next property says liquids show fluidity. Now what is fluidity? Fluidity is the property of a substance to flow from one point to other. So as we know, the liquids can flow. If I pour water, then it will start flowing from one point to other. So this property of liquids is known as fluidity. So liquids show fluidity, whereas solids don't show fluidity. They retain their shape and don't flow. Now next property says liquids have lesser density than solids but high density as compared to gases. Now just now I have told that the particles of liquid are somewhat loosely packed. So the density of liquid is lesser than that of the solid, but it would be higher than that of the gases. Liquids are almost incompressible. What does it mean? Like if I want to press liquid, is it possible? No, I cannot compress a liquid. So they are incompressible as there is only small space between the particles of liquid. Though it is more than that of the solid, yet they are not compressible. The kinetic energy of liquid particles is more than that of the solids. Now we have seen as the particles are loosely packed, there is some space between the particles, so they are a bit free to move from one point to other. That's why they possess more kinetic energy as compared to that of the solids. The rate of diffusion in liquids is faster than solids. And solids, liquids and gases can be diffused in liquids. Now just in the previous slide we have discussed what is diffusion, that is intermixing of one matter into other on its own. So in liquids, since there is a small gap between the particles, different matters can diffuse in it. If you remember our previous video in which we have learned the example of dissolving salt or sugar in water. So the solids can get dissolved in liquids. Similarly, liquids like ink or honey, it can diffuse in liquid. Now, gases are also diffused in liquids. The best example is the water where aquatic animals live. The water have oxygen, carbon dioxide and other gases diffused in it. And this diffused oxygen survives the marine life. Now let's see the properties of this diffusion. The rate of diffusion increases with temperature. What does it mean? Say if I increase the temperature of a liquid or I heat a liquid, then the diffusion will take place quickly. You must have observed, like if your milk is hot, then the sugar get dissolved in it easily as compared to the cold milk. So this is because the rate of diffusion will increase with temperature. As I heat the liquid, that is the milk, the rate of diffusion will increase and the solid will get dissolved in it easily. The next point says the rate of diffusion is different for different substance. Say when I am mixing any substance, say if I add an ink drop in water, then it would take some time to get dissolved completely or to spread in the water completely. Whereas if I put a drop of honey, it would take a longer time to diffuse in water. So it depends from substance to substance how the diffusion will take place. So the rate of diffusion is different for different substances. The gaseous state. The substances which do not have a definite shape and fixed volume are called gases. So the gases, they don't have a fixed shape and a fixed volume. They take the shape as well as the volume of the container in which they are stored. So some of the example of gases are the air we breathe, the steam coming out from hot cup of tea, the smoke coming out of incense stick. So these are the few examples of gases. Now in gases, the particles are very loosely packed. So you can see here the particles in gases are very far apart from each other. They are very loosely packed. And hence these particles have negligible force of attraction between them. As they are quite far away from each other, the force of attraction is also less. Let's see the properties of gaseous state. Gases do not have a fixed shape. They take the shape of the container in which they are stored. Gases do not have fixed volume, as the kinetic energy of the particles of gases is very high. They can move easily and hence occupy all the given space. Gases show high fluidity, that is, the ability to flow. Since the gases have very low intermolecular attraction, they can flow easily. Gases have very low density. Just now I have told you that there are very less particles per unit volume in gases. That's why they have very low density. Gases are highly compressible because the particles of gases are far apart from each other under normal conditions. So when pressure is applied, these particles get accommodated in these gaps and hence we can compress the gas particles. And that's why we can get the compressed natural gas, which is obtained by compressing the gases at very high pressure. The kinetic energy of gaseous particle is very high. Since there is very less intermolecular force between gaseous particles and a lot of space is there in between them, they can move easily and hence have very high kinetic energy. The rate of diffusion in gases is very high. Again, the reason being high kinetic energy. So these particles move very quickly and hence get diffused easily. Gases exert pressure on the wall of container in which they are stored. Since the particles of gases have very high energy, they keep on colliding with each other and with the wall of container and thereby exert a force on the wall of container in which it is stored. This force exerted by gases per unit area is known as the pressure. Thus, the gases exert a pressure on the wall of container. As I have mentioned in the first slide that there are 5 states of matter, let's see what are the 2 other states of matter. So the 4th state of matter is plasma. This state exists at a very high temperature. This state consists of free electrons and ionized gases. So the particles in this state are super energetic and highly excited. This state of matter has very low density. We can see plasma in our daily life in the fluorescent tube and the neon sign bulbs. The sun and the stars, they also glow because of the plasma present in them as they are having very high temperature. Now the 5th state of matter is Bose-Einstein condensate. The Bose-Einstein condensate is called as BEC, is the 5th state of matter which exists at very low, or I can say ultra low temperature, which is nearly equal to 0 degree Kelvin. This Bose-Einstein condensate is found by cooling the gas of very low density to super low temperature. In this state, the whole matter behaves as a single atom. This phenomenon was predicted by Indian scientist Satyennath Bose and then generalized by Albert Einstein. And from here only this state got its name Bose-Einstein condensate. So, students, now you can write the answers to these questions based on the knowledge we have gained in this session. So, that's all for today's session. Thank you, children.